All right, let's talk about one of the most powerful, absolutely essential tools in any programmer's toolkit, functions. Seriously, if you've ever wanted to write code that's cleaner, smarter, and just, well, better, then you are in exactly the right place. I want you to imagine something. Picture yourself trying to cook a big meal in a kitchen where every single time you need to make some dough, you have to write the entire recipe out from scratch. Grab the flour, measure the yeast. It would be a total nightmare, right? Well, that's pretty much what coding without functions is like. It's repetitive, it's chaotic, and it's basically a recipe for disaster. So let's really zoom in on this code kitchen problem. You know that feeling when you find yourself copying and pasting the same chunk of code again and again? Your project doesn't just get a little messy, it becomes this tangled beast that's incredibly hard to manage or update. And this, right here, is what I'm talking about. On the left, you've got that tangled, repetitive mess. Every time you need to do something, you're writing out all the steps again, which just leads to chaos. But now, look at the right. So much better. By packaging those steps into one single, reusable block, a function, you get this clean, organized structure. It's just so much easier to read and to manage.
And that, my friends, brings us to the beautiful, elegant solution. Functions are basically the recipe cards for your code. You write the instructions down once, you give that recipe a name, and then you can pull it out and use it over and over and over again anytime you need it. So let's get a clear definition here. At its heart, a function is just a named, reusable chunk of code that's built to do one specific thing. You can really think of it as the most basic building block for writing clean, modern software. So why do we care so much? Oh, the benefits are massive. Functions let us wrap up complicated logic into a single, easy-to-understand unit. This makes our code modular, kind of like building with Legos. We can reuse these pieces, test them one by one, and snap them together to build really powerful programs, all while keeping everything tidy and organized.
And hey, this isn't just some high-level text-only coding thing. If you've ever played around with Scratch, you've already used this idea. Creating a custom block is the exact same concept. You're bundling up a bunch of instructions into a single, reusable piece. It just goes to show how universal and fundamental this idea really is.
Okay, so now that we know why they're so great, let's actually roll up our sleeves, take one apart, and see what makes it tick. We're going to go piece by piece so you can see exactly how it all fits together.
To really get how a function works, just think of it like a little machine. You give it some input, it does some work based on a set of instructions, and then it gives you back an output. Even a super simple function like this one follows that exact pattern, and it has a few key parts we need to look at.
Let's break this recipe down. First, you've got the key word, which is like shouting, "Hey, I'm writing a new recipe." Then you give it a name, so you know what to call it later. The parameters inside the parentheses are your ingredients, the stuff your recipe needs to work with. The body, everything inside the curly braces, that's the actual step-by-step instructions. And finally, you have the return value. That's the finished dish that your function serves back to the rest of your code. Oh, and here's a super important little detail. Any temporary bits of data you create inside a function's body, they stay inside that function. This idea is called scope, and it's fantastic, because it's like giving each recipe its own clean little workspace, which stops your different functions from messing with each other's ingredients. Okay, recipe's written down, it's in our cookbook. Now for the best part, it's time to actually use it. It is time to cook. There's a perfect way to think about this. Just because you've written down the recipe for a cake doesn't mean you have a cake sitting on the table. You still have to get out the ingredients and follow the steps. That's exactly what calling a function is. It's the cooking part.
And this right here is a mistake we've all made when starting out. Step 1, defining the function, is just writing the recipe. It's sitting there in your cookbook, but it's not doing anything yet. To actually make it run, you have to do step 2. You have to call it by writing its name with parentheses. That's the magic command that actually kicks off the whole process.
Okay, so usually when you call a function, everything else in your program just waits. It's called a synchronous process, one step at a time in a nice, neat line. But sometimes you want to kick off a task and let it run in the background while you do other things. That's asynchronous, and it's more like sending out a broadcast message that tells another part of your code, "Hey, do this for me whenever you get a chance."
All right, you ready for a pro tip? Because this is where things get really interesting. The way you give a function its ingredients, its inputs, can sometimes have some really surprising results. So let me ask you a question. When you pass some data into your functions recipe, are you handing it a fresh copy of that ingredient, or are you giving it the actual container from your pantry? The answer is, well, it depends on the ingredient.
For simple stuff like numbers or text, it's passed by value. This means the function gets a brand new copy. Anything it does to that copy won't affect the original at all. But for more complex things like objects or arrays, it's passed by reference. The function gets a direct link, a pointer, to the original data. If you change it inside the function, you are changing the one and only original. And let me tell you, understanding this difference is absolutely critical.
And guess what? If you're a Scratch user, you've already seen this in action. Both variables and lists in Scratch act like they're passed by reference. If one of your custom blocks changes a list you gave it, the original list outside that block is changed too. It works just like a JavaScript object.
So how do we avoid, shooting ourselves in the foot with this? Well, there are a few golden rules. The best practice is usually to avoid changing or mutating the original data. Instead, it's often way safer to create a brand new, modified version of your data inside the function and just return that. It prevents all sorts of unexpected side effects and makes your code way more predictable. So, if you take away just one thing from all of this, let it be this. Functions aren't just some neat little feature. They are the absolute, fundamental building blocks of pretty much all modern software. They're how we build programs that are clean, efficient, and, maybe most importantly, easy for other people to read and understand. When you really embrace functions, you're making a huge leap. You're transforming yourself from someone working in that messy, chaotic kitchen into an organized chef who has a perfectly cataloged set of reliable recipe cards. It really is the key to taking control and mastering your code.
And that's our look at functions. So I'll leave you with this to think about. As you go forward, as you build your own amazing projects, what essential reusable recipes will you write for your code?